Ever written a tool that works perfectly in development, only to fail silently when an AI tries to call it with unexpected inputs? You'll see how FastMCP automatically generates JSON schemas from your Python type hints, then locks them in with snapshot testing to catch breaking changes before they reach production. This pattern ensures your tools stay compatible with AI clients, even as your code evolves. From inline-snapshot, import snapshot. Async def test tool schema generation. Test that tool schemas are generated correctly. MCP, FastMCP, test server. At MCP, tool. Def calculate tax, amount, float rate, float equals 0.1, dict. Calculate tax on an amount. Return, amount tax, amount rate total, amount 1 plus rate. Tools equals MCP, list tools. Schema equals tools 0, input schema. Hash first run, snapshot, is empty, gets auto-populated. Hash subsequent runs, compares against stored snapshot. Assert schema equals snapshot. Type, object. Properties. Amount, type, number. Rate, type, number, default, 0.1. Required, amount. This demonstrates snapshot testing for schema validation, a technique that verifies API contracts remain consistent over time. The pattern captures the expected structure of generated schemas during the first test run, then compares future outputs against this golden master. What makes this distinctive is its ability to detect breaking changes in tool interfaces automatically, without manual assertion maintenance. The approach works by leveraging the inline-snapshot library to store verified outputs directly in test files. During test execution, the framework compares current schema generation against the stored snapshot, failing if discrepancies appear. This creates a self-documenting test where the expected structure lives alongside the verification code, making contract changes explicit and reviewable. This matters because it solves the problem of API drift in evolving systems. As you add features or modify tools, snapshot tests catch unintended interface changes that could break clients. The technique is particularly valuable for RPC frameworks like FastMCP, where tool schemas serve as the contract between AI models and backend services, ensuring backward compatibility without manual schema assertions. Let's break it down. From inline-snapshot, import snapshot. Imports inline-snapshot, a PyTest extension for auto-generating test assertions. It captures the current output on first run, then validates against that snapshot in future runs, eliminating manual assertion maintenance. Async def test tool schema generation. Test that tool schemas are generated correctly. MCP, FastMCP, test server. This defines the test function for validating tool schema generation. The FastMCP instance, named MCP, serves as the test server context, providing the decorator and tool registration system we'll test against. At MCP, tool. Def calculate tax, amount, float rate, float equals 0.1, dict. Calculate tax on an amount. Return, amount tax, amount rate total, amount 1 plus rate. This decorator exposes calculate tax as an AI callable tool through FastMCP. The type hints and docstring automatically generate the tool's schema, while the default parameter value becomes part of the schema's validation rules. This pattern ensures consistent, self-documenting tool definitions that AI models can reliably invoke. Tools equals MCP, list tools. Schema equals tools 0, input schema. This retrieves the registered tools and extracts the input schema from the first one. The schema defines what parameters the AI can pass to the tool, ensuring type safety and proper validation.
Assert schema == snapshot. Type object.
This uses inline-snapshot to auto-generate test assertions. On first run, it captures the actual schema output, then verifies against this snapshot on subsequent runs. The pattern eliminates manual assertion writing while preventing regressions in tool schemas. Schema generation pattern. FastMCP automatically generates JSON schemas from Python type hints, creating a bridge between static types and dynamic AI interactions. The snapshot test only verifies the input schema, not the actual tool behavior or output structure. Always validate both schema generation and runtime behavior in your tests.
The schema that describes everything must itself remain undescribed.